Hello students, in this video we will start from unit first, introduction to embedded system. In that first we will see first point, that is block diagram of embedded system with hardware components. As its name suggests, embedded means something that is attached to another thing. An embedded system can be thought of as a computer hardware system having software embedded in it. An embedded system can be as independent system or it can be a part of large system. An embedded system is a microcontroller or microprocessor based system which is designed to perform a specific task. For example, a fire alarm is an embedded system. It will sense only smoke. An embedded system is a system that has software embedded into computer hardware, which makes a system dedicated for an applications or specific part of application or a product or a part of large system. In simple words, embedded system means hardware plus software dedicated for a particular task with its own memory. These are some applications of embedded systems. Take one example of embedded system in our day-to-day life, that is washing machine. In washing machine, different programs are stored in its memory for different options provided. Means according to clothes, when we select a program by pressing a particular button, then machine starts to execute a program stored in its memory. It takes water for a time as per the program only. It senses level of water using sensors. If it achieves as per target level, machine stops to take water in its drum and starts to wash clothes. Like this, machine completes selected task according to program only and give us notification for a completion. There are different sensors, actuators, memory to save the program, power unit, processor to execute a program, timers, interrupts, controller, etc. So it is the base example of embedded system. So these are some applications of embedded system. This is the block diagram of embedded system. First we will see processor. Processor is the heart of embedded system. It is responsible for execution of instruction and controlling flow of data to and from processor. Designer should have proper knowledge regarding efficiency of different types of processor and based on which one should select the appropriate processor as per requirement. A processor has two essential units. First is program flow control unit, that is CU, and execution unit, that is EU. The CU includes fetch unit for fetching instructions from memory. The EU has circuits that implement the instructions pertaining to data transfer operations and data conversion from one form to another. The EU includes the arithmetic and logic unit and also the circuits that execute instructions for program control tasks, halt, interrupt or jump to another set of instructions. It can also execute instructions for a call or branch to another program and for a call to a function. A processor runs the cycle of fetch and execute. The instructions defined in the processor instruction set are executed in the sequence that they are fetched from the memory. The processor is in the form of IC chip. Different processors are used in embedded system like microprocessor, microcontroller, DSP or image processor, etc. Next is the Power supply unit. Generally, embedded system has its own power supply unit. Four ranges of voltage are used: 5 volt, 3.3 volt, 2 volt, 1.5 volt. Additionally, 12 volt plus zero point 0.2 volt supply is needed for a flash or EEPROM and RS-232 serial interfaces. Supply of voltage to the chip depends on number of pins provided in the chip, which is generally in pair supply and ground. A processor may have more than 2 pins of VDD VSS, which are responsible for distribution of power and reduction of inferences in all the sections. Supply should separately power the external I/O driving port, timers, clock, and reset circuits. Embedded systems which don't have power source at their own are either connected to an external power supply or use charge pump for necessary power supply. An embedded system has to perform tasks continuously from power up to power off and may even be kept on continuously. Real-time system, that is RTOS, use wait and stop instructions and disabling certain units when not needed. This indeed is very important for saving power during program execution. Performing tasks at reduced clock rate is also a way to control power dissipation. Performance of software analysis during design phase can include power dissipation considerations also. A good design must optimize the conflicting needs of low power dissipation and fast, efficient program execution. Next we'll see clock oscillator. The function of this oscillator circuit is to provide an accurate and stable periodic clock signal to a processor. The processor needs a clock oscillator as clock controls the various clocking requirements of CPU. The clocking requirements are the system timers and CPU machine cycles. The machine cycle includes fetching code and data from memory and decoding and execution and transferring results to memory. The clock controls the time for executing an instruction. The clock circuit uses either a crystal or a ceramic resonator or external IC attached to the processor. Next, we'll see timers. A timer is suitably configured as system clock, sometimes referred as RTC, that is real time clock. RTC is used by scheduler for real time programming. A hardware timer is a counter that is incremented at a fixed rate when the system clock pulses. There are several different types of timers available. A timer or counter can perform several different tasks. The CPU uses the timer to keep track of time accurately. The timer can generate a stream of pulses or a single pulse at different frequencies. It can be used to start and stop tasks at desired times. There may be hardware and software implementations of timers. At least one hardware timer device is must in a system which is used as system clock. The hardware timer gets the input from a clock out signal from processor and activates the system clock as per the number of ticks present at the hardware timer. Number of hardware timers present are generally limited. A software timer is a software that executes and increases or decreases a count variable or count value. or an interrupt on timer output, or on a real time clock interrupt. A software timer can also generate interrupt on overflow of count value or the final value of count variable. Software timers are used as virtual timing devices. Next we see interrupt handler or interrupt controller. A system possesses a number of devices and the system processor has to control and handle the requirements of devices by running appropriate interrupt service routine for each. An interrupt handling mechanism must exist in each system to handle interrupt from various processes in the system. An interrupt is an event that suspends regular program operation while the event is serviced by another program. Interrupts increase the response speed to external events. Different microcontrollers have different interrupt sources, which can include external timer and serial port interrupts. When an interrupt is received, the current operation is suspended, the interrupt is identified, and the controller jumps or vectors to an interrupt service routine. There are two sources of interrupt, hardware and software. Hardware interrupts include a signal to a pin, timer overflow, and serial port. Software interrupts are commands given by the programmer. There are two types of interrupt signals, that is maskable and non-maskable. Maskable interrupt can be disabled and enabled, while non-maskable interrupts cannot be disabled and are therefore always enabled. When a specific interrupt occurs, the interrupt handler automatically branches to an address associated with that interrupt. Next, we'll see reset circuit. Reset instruction starts execution from starting address. Otherwise, execution starts from this address when it is powered up. The reset circuit activates for a fixed period and then deactivates to let the program proceed from a default beginning address. On deactivation of the reset that succeeds the processor activation, a program executes from startup address. Reset can be activated either by external reset circuit that activates on power up or by software instruction or by a programmed timer known as watchdog timer. Watchdog timer is a timing device that resets the system after predefined timeout. This time is usually configured and the watchdog timer is activated within the first few clock cycles after power up. Next we will see memory. Embedded system makes use of different types of memories based on their application. These are internal RAM used for registers, temporary data and stack, internal ROM, PROM, EPROM for application program, external RAM for temporary data and stack, internal cache available in case of some microcontroller or microprocessor, EEPROM or flash memory for saving the results, external ROM or PROM for embedding software used in non-microcontroller based systems. RAM memory buffers at ports